So I want to start today with some of these sort of warm-up practice problems. It's kind of a review of some of the skills that we're going to need for what we're going to look at for today. So yesterday we looked at vertex form and we looked at how to graph these quadratic functions. Today we're going to take a look at another format that we have for quadratic functions called standard form, and we're going to look at how to move between the two, between vertex form and standard form. In order to do that, I wanted to do a little refresh on things like order of operations and distribution. Those are some skills that we're going to need. So if we take a look at our page of practice problems, the top section are all order of operations questions. So as we're looking at being able to simplify, I want you to keep in mind order of operations. So I have 2 plus 48 over 6 times 5. I don't want to just do this from left to right. I want to follow order of operations. So order of operations says for this problem that I want to prioritize the multiplication and division. Now, I want to point out here that this term in the middle looks like a fraction, but remember that also means division, okay? So I'm saying 48 divided by 6. I can simplify that. I'm going to tackle this guy first. What is 48 divided by 6? 8. And there's a second reason I want to simplify that division instead of treating it like a fraction. It makes my multiplication a little bit easier. So now 8 times 5 gives me 40. And then I'm going to add 2, and we get a final answer of 42. So I'm following my order of operations. For number 2, same idea. This time, my most important operation is that exponent. So I'm saying -3 squared. Remember, when I see something squared, that means that number times itself. So -3 times -3. That would give me +9. So here I get 9. 6 plus 9 would give me 15. For number 3, I've got an exponent again, but if I look inside my parentheses, I have something that I can simplify. So I'm going to go ahead and simplify inside those parentheses first. So I've got -28 divided by 7. That would be -4. Then -4 squared would give me 16. And then finally, again, I want to simplify inside those parentheses. We're going to see some stuff like this a little bit later on in our unit. I want to simplify inside those parentheses. So -4 minus 2 is -6. -6 squared is 36. While we're talking about order of operations in this format, I want to remind you that if I had something like 2 times -3 squared, that the multiplication. So -3 squared and then multiply by 2. It's a pretty common error I see when we get into quadratic functions and putting values in for x. So just remember those order of operations is going to tell you to do the exponent first, then multiply. Questions for me so far? Okay, so for the next sort of chunk of our problems, we're looking at problems where I've got to do some distribution. So remember, when I've got something multiplied by a quantity, something in parentheses, that means that I want to take this -2 and multiply it by each term inside of those parentheses. So -2 times x, and then -2 times 3. And then same idea here. Before I can do any addition, I have to first distribute the 7. So that would be plus 7x. And then 7 times 3 would be plus 21. Once I've distributed, I want to simplify this by combining my like terms. So like terms means x terms that have the same exponent, constant terms, those things with no variable, x terms versus y terms, stuff that has the same sort of label, if we think about it that way. So I'm going to combine my -2x with my 7x. And that would give me -2x plus 7x would be 5x. So my coefficient has changed. -2 plus 7 gives me 5, but my x hasn't changed. That stays the same. And then for my constant terms here, my things without variables, Negative 6 plus 21 would be 15. So I would get 5x plus 15 there. If we hop down to number 7, we're going to distribute this negative 2x to each term inside parentheses. So negative 2x times 3x squared, I'm going to multiply those coefficients and I get negative 6. And then I have x times x squared. And remember, x squared is x times x. So what I would get here is x cubed. When I'm multiplying variables, that's where I can see a change in that x. And then negative 2x times negative 5x would be positive 10x squared. And then negative 2x times 10 would be negative 20x. Since all my exponents are different here, I don't have like terms to combine. So this is going to stay exactly as it is. Questions for me so far? Okay, let's hop back up to number 6 here. I've got a quantity times a quantity, something in parentheses times something in parentheses. So this is where we're going to do what we sometimes call double distribution. So we're going to take this term and multiply it by each part in here. And then we'll take this term and multiply it by each part over here. So 2x times x would be 2x squared. And then 2x times 5 would be 10x. Negative 4 times x would be negative 4x. And negative 4 times 5 would be negative 20. You take with your signs as you're distributing. And then my last step here is to combine like terms. So I'm going to combine my x terms. That would give me 2x squared plus 6x minus 20. The last problem we're going to look at on this paper is number 8, where we've got some subtraction. For number 8, we're subtracting this whole quantity. That means I want to subtract each of these terms inside the parentheses. This is another place where I see some mistakes pretty frequently. A lot of times we remember to subtract that first term because the subtraction sign is right in front of it. But then we forget that we're subtracting for those later terms. So when I subtract, that means all of these signs should change. So I'm going to go ahead and write that right now. So minus 9x squared, and then minus negative x would be plus x, minus negative 3 would be plus 3. So I'm going to go ahead and change those signs right now. That way when I combine my like terms, I don't have any sign errors. So now I can combine my like terms. So 2x squared minus 9x squared would be negative 7x squared. Negative 8x plus x would be negative 7x. And then 3 plus 3 would be 6. Questions for me on any of our review problems for today? Okay, again, we're going to see a lot of distribution today. We're going to see a lot of combining like terms today. We're going to need to follow order of operations. We're going to see this a lot, okay, which is why I want to take some time to review this. So let's hop back into our notes. We're going to start on page 7 for today. So if you have not already, go ahead and get out your notes and let's take a look at page 7. So again, last time we talked about vertex form, and we know this is what vertex form looks like. That a value in front, that lead coefficient, tells me about the shape of my parabola. Tells me if I'm going to open up like a U or down like an umbrella. It tells me if I'm going to be sort of stretched out or compressed, or if I should maintain that original shape. And then H and K, the values that go here, tell me the vertex of my parabola. Today, we're going to take a look at standard form as well. So we're going to see some vertex form functions, but we're also going to learn about standard form. Standard form looks like this. Notice we still have that A in front, that lead coefficient. A here and A here are exactly the same. They tell us all the same stuff. How's my parabola going to open? Is it going to be stretched out? Is it going to be compressed? Do I need to flip it? And in fact, if I'm looking at the different formats of a same function, this A number will be exactly the same as this A value, okay? So for the same function, they'll be the same number. The sort of new thing that we get from our standard form is this C value tells us the y-intercept of our function. So vertex form gave us the vertex, standard form is going to give us the y-intercept. So let's take a look at a couple of examples. We're going to start by taking a vertex form function and changing it into a standard form function. So for standard form, we want to basically multiply this out and combine all of our like terms. So that's what we're going to do here. Now, if you remember a minute ago, we had an x squared, and I reminded you that means x times x. And we had a -3 that we were squaring, and we said that means -3 times -3. So here where I have x minus 1 squared, that means x minus 1 times x minus 1. So following order of operations, I want to multiply these together first. I want to do my distribution first. X times x gives me x squared minus 1x minus 1x plus 1. And then again, I still have that other plus 1 at the end. And now I'm going to combine my like terms. So I've got x squared minus 1x would be minus 2x. And then plus 1 would be plus 2. From vertex form, I know that the vertex of my parabola should be 1, 1. From standard form, I know that the y-intercept of my parabola should be 2. Now I'm going to hop over to my calculator, and I want to show you something. So I'm going to graph the original function I had on my paper. I'm going to graph the vertex form that we were given. So x plus 1 squared, or actually that's x minus 1. Go ahead and fix that. X minus 1 squared plus 1 at the end. So here's our parabola. Here's our graph of our quadratic function. If I want to find the vertex of this on my calculator, I don't have to guess. I can have my calculator find it for me. Our vertex is going to be this bottom value right here. So I'm going to go to menu, analyze graph, and have it find that minimum for me, that minimum value. And it's 1, 1. That matches what we picked out of our function, 1, 1. And now I'm going to go ahead and graph. I'm going to hit the tab key, and I'm going to graph our standard form equation. So x squared minus 2x plus 2. Where'd my blue graph go? Why don't I see the blue graph anymore? It's covered completely by the red one, right? So the blue was our vertex form. The red is our standard form. They match up completely. That's what I want to see. That's how I know I've done this correctly. If I graph the original problem and I graph what I've rewritten it as, and they're the same, I know I've correctly changed this to standard form. If I didn't do this correctly, they wouldn't match up perfectly, okay? And I may not necessarily be able to tell from my graph what the problem is, but I can see if they're different, that I need to go back and double check my work. Now, the other thing I want to show you is from standard form, we said we should be able to see our y-intercept. So that would be 2 for this one from standard form. If I look at my graph, it looks like my y-intercept is at 2, but I can also use my calculator to double check this. So I'm going to pull up my table of values for this thing. I'm going to hit Control T to pull up my table of values. And remember, the y-intercept happens when x is 0. So I'm going to scroll up to where x is 0 and my y value is 2. So my y-intercept here is at 2. So I can use my calculator to double check all of the work that we just did. Questions for me so far? Okay, let's try another one. So for example 2 here, same idea. This time I've got a number in front. I've got a lead coefficient of 2, an a value of 2. That's okay. I'll end up distributing that as well. But I'm going to start with the x one. I'm going to start with this 3. So that's x plus 3 times x plus 3 that I want to take care of first. So gives me x squared plus 3x plus 3x plus 9. And remember, this all is still really in parentheses with that 2 in front, and we're subtracting 5 at the end. I'm going to go ahead and combine like terms here. So this would be x squared plus 6x plus 9. And now that I've done the squaring, I'm going to distribute in my 2. So that would be 2x squared plus 12x plus 18. And then still that minus 5 at the end. My last step here is to combine my last like terms. So my standard form quadratic function would be 2x squared plus 12x plus 13. From vertex form, I expect my vertex to be -3, -5. And my y-intercept from standard form should be 13. Now let's head on over to our calculator and check this. I'm going to put my table away and get rid of these graphs. And we'll graph, again, our vertex form, what we had on our paper originally. So 2 times x plus 3 squared minus 5. And I'm going to double check my vertex. Again, since this is the lowest part of my graph, I'm going to find the minimum. If I had a vertex or a parabola, I should say, that was opening down, upside down, my vertex would be my maximum point, since it would be the highest point of my graph. But again, here it's our minimum. So find that minimum, and it's at -3, -5, just like we said. And then I'm going to go ahead and graph our standard form. So 2x squared plus 12x plus 13. It completely covers my blue graph, so I know I've transformed that correctly to standard form. And then again, we can check our y-intercept. So if I bring up my table here and I scroll up to when x is 0, I can see my y-intercept is 13 again. Okay, so you can check this using your calculator. Questions for me so far? Okay, go ahead and turn to the next page. And we've got a couple more practice problems that we're going to do with this. So we've got in this table at the top of page 8, a couple of parabolas in vertex form. Now I want you to notice that we don't see a number here at the end. So that means our y value for these vertices is going to be 0. So our vertex for this guy would be -3, 0. For this guy, -4, 0. Then 2, 0. That's okay. We want to convert these to standard form. So where I have x plus 3 squared, I need to write another x plus 3, and then distribute. So I would get x squared plus 3x plus 3x plus 9. For standard form, I need to combine my like terms. So I would get x squared plus 6x plus 9. And then the last thing I'm asking you to identify here are your b and c values. So b is the coefficient for x. That would be 6 on this one. And c is that constant term at the end. So that would be 9 for this one. I want you guys to try the next 2 problems. Convert them to standard form. for x plus 4 squared, to change that to standard form, I've got to distribute. So I would have x squared plus 4x plus 4x plus 16. Combine our like terms to change this to standard form. So I get y equals x squared plus 8x, oops, yeah, plus 16. My b value is 8. My c value is 16. And for x minus 2, this would be x squared minus 2x minus 2x plus 4. Combine our like terms, and we have x squared minus 4x plus 4. Our b value is negative 4. Our c value is positive 4. Now let's take a look at how we go the other way. So we can get from vertex form to standard form by distributing and combining like terms. We want to now go from standard form to vertex form. My b here is 14. My c value is 49. So to get this 14, we combine two x terms. If I look at my standard form versus my distribution here, I can see that I had 3x plus 3x got 6x. I had 4x plus 4x and got 8x. I had negative 2x and negative 2x and I got negative 4x. So what do you think gave us 14x? 7 and 7, yeah. These numbers here are half of our b value, or half of our b value. So my distributed work, I would expect to look like this. Instead of 14, I should have had 7x and 7x. Now, I also want to point out that 7 times 7 would give us 49. Just like negative 2 times negative 2 gave us 4, and 4 times 4 gave us 16, and 3 times 3 gave us 9. That cut in half number, if I multiply it by itself or if I square it, I get that c value. So as I continue to work backwards to figure out what did I square to get this when I distributed, it would have to be x plus 7. Because if I took x plus 7 times x plus 7 and distributed, I would get x squared plus 7x plus 7x plus 49, which is exactly what we had here. Okay, so that's what we're looking at now. It's working backwards to that vertex form. For our next example, same idea. We have standard form. Our b value is negative 20. Our c value is 100. So we want to split this negative 20 up the same way we split up our 14. So I would have x squared. How do I want to split up that negative 20x? To negative 10 and negative 10, two negative 10s, minus 10x plus 100. And this had to have come from x minus 10 squared. The last part we need to check is if I take negative 10 times negative 10, do I get 100? Yeah. Now for the last two, they gave us the b and the c values. So we're going to use those to write standard form. This would be y equals x squared minus 12x plus 36. So I'm going to split that negative 12x. It would be minus 6x and minus 6x. So then what would be my vertex form for this guy? I follow the same pattern as the other problems. Yeah, x minus 6 squared. And then for our last one, same idea. There's my b and my c values. So I know standard form would be x squared minus 6x plus 9. I'm going to split that negative 6x. So x squared minus 3x plus 9. And I got this by multiplying x minus 3 by x minus 3, or x minus 3 squared. Now, here's the kind of issue that we have. For all of the problems that we looked at in our table, the y-coordinate for our vertex was 0. But we know that the y-coordinate for our vertex is not always going to be 0. We still want to be able to get vertex form from standard form, even if that y-coordinate is not 0. So we're going to use a really similar process, but with a couple sort of modifications. This is called completing the square. And the idea is we want something like this to be a part of our problem. We just may not have this nice C value already. Okay, so that's what we're going to look at with our last few examples. So if we take a look at example 3, I'm going to start this the same way we started the problems in our table. So I'm going to take that B value and split it in half. So that would be x squared plus 5x plus 5x. But now the problem is, for all of my other problems, if I took that cut in half number and squared it, I got that last number, right? Negative 3 squared is 9, negative 6 squared is 36, 7 squared is 49, 4 squared is 16. 5 squared is not negative 7. What I want here is 5 squared. What I have is negative 7. So I can't just throw away the negative 7. That changes the problem. But what I can do is kind of scoot it back out of the way and then fill this blank in with the number that I want, which is 5 squared, or 25. Now, just adding 25 to the problem is going to change it. So I also can't just add 25 and call it a day. Since I added 25 to keep this balanced, to make sure it stays the same, I also need to take away 25. Because if I add it and then take it away, it's not going to change the problem, right? But I'm going to add it and take it away in some strategic places so that I can still do what I want to get vertex. Okay, what I want is to be able to write this part of my function as something squared. And I can do that now because this part follows the same format that we saw in our table here. So this part would be x plus 5 squared. And now for this part, I'm just going to combine those like terms. So negative 7 minus 25, that would be negative 32. And there I have vertex form for my function. My vertex here would be negative 5, comma, negative 32. Questions on example 3? Okay, so we're going to do this again with example 4. Same idea. I'm going to split the middle guy. I'm going to split that b term. So I have x squared plus 4x plus 4x plus something, not 11. I don't want 11. But I can't throw out 11, so I'm just going to scoot it over. And then whatever I add, I'm also going to have to subtract to the end. Now I want to fill in the blank with that cut in half number squared. So 4 squared is 16. So I'm going to fill in my blanks with some 16s. Now this part follows the same format as what we had up here and is actually right there, right, with our 4s and our 16. So this part would become x plus 4 squared. And then we combine our like terms at the end. 11 minus 16 would be negative 5. So there's our vertex form for our function. Let's type one more together. So for example 5, same idea. We're going to split up this middle term. We're going to cut it in half. So x squared plus 2x plus 2x plus something. I don't want 10. I can't throw out the 10, so I'll just move it away. And then whatever I add, I have to also subtract. I'm going to fill in the blank with our cut in half b number squared. 2 squared is 4. Now this part I can write as x plus 2 squared. And this part, I'm going to combine my like terms and I get plus 6. So there's my vertex form. I want you guys now to try example 6. Try example 6. Okay, for example 6, cut that negative 6x in half. That'd be minus 3x plus something plus 7 minus something. What do I want to fill in here? 9. Negative 3 squared would be 9. This part becomes x minus 3 squared. Combine like terms at the end, and we have minus 2. Now, just like earlier, I graphed my vertex form and graphed my standard form, and they were the same. That was how I could check my work. You can do the same thing with these. Graph your standard form, graph your vertex form. You should get the same thing. They should overlap completely like they did on the first couple of examples that we did. The other thing that I want to show you, the other way that you can check this is to take your vertex form function and distribute it back out, multiply it back out. So take your x plus 2 times x plus 2 and distribute. So x squared plus 2x plus 2x plus 4 plus 6. Combine your like terms. And what you get when you distribute should be the same thing that you originally had. So if I take my vertex form and multiply it back out, I should get the standard form I started with. Okay, that's the other way that I can check these. Questions for me for today? Okay, so for homework, I want you to work on pages 9 and 10. On page 9, you've got equations in vertex form. You're going to change them to standard form. Identify your vertex and your y-intercept for me. On page 10, you've got standard form. You're going to change them to vertex form. Again, give me your vertex and your y-intercept.